Hello, Daniele. Can you hear me? We can hear you actually. Thank you, Agent.
I can't.
There's really 5 people in Ccamp.
Now it seems to work on my side.
Okay, Daniele.
No, I can't hear you. Okay, I'll
Fatai, if you can hear me, let's try to
Yeah.
start. Yeah. Okay, now I can hear you. Wonderful.
Okay, sounds good. Yeah, I think we can start, right? Yeah. Okay, guys, let's start. So, welcome to Ccamp session, and good morning, good afternoon, good evening. So I'm sorry that at the church we both cannot make the trip to attend the meeting physically. So sorry about that. So let's start from the loadware. So actually, I think we are all familiar with the loadware information. Actually, this is the kind of reminder for the IETF policies, which means that by participating in the IETF, you agree to follow IETF policies and IETF process, including IETF patent policy. And also, if you would like to get more information about the loadware, you can have a look at the BCP documents in the below. Next. And also, there are a couple of tips that we should be aware. This time, this meeting is a kind of mixed meeting. So, including in-person participants and the remote participants. So, there are some tips for the on-site, participants. First, we have to make sure to sign into the session using the online tool, Meet Echo, and also use the Meet Echo to join the mic queue. And especially, please keep audio and the video off if not use the on-site version. And the last one is very important because it's relevant to our health. So please wear masks unless when you're speaking at the mic. And for the remote participants, we also have to make sure your audio and the video off unless you are speaking, you are chairing or presenting something to avoid internet bandwidth competition. And also we recommend to use a kind of headset to make you much clear. Next. And there are some information about this meeting, like the agenda and the Meet Echo. You can just open the links. Next. So there is also some conduct guidelines. I think this is more like a kind of supplement to the noteware. This things more described in the BCP 54. In summary, actually, it says that anyway, we should be polite and respect each other at all times. I think this is quite very important. No personal attack. We can only just focus on the technical stuff. Next. And for session, this time we have only one session with 2 hours. Actually, I don't think the time is friendly for the, especially for the remote participants, for the Asian people, but also it's not friendly for the in person participants, because this is a Friday afternoon. Maybe some in person participants may leave for home at this time. Okay, next. So this agenda. So this time we have 9 presentations. So this still a kind of busy agenda. So let's follow the agenda and let's have a an efficient discussion. So administrative, actually we are using the Meet Echo. I think we know how to use it. Yeah. Next. So for the meet takers, I think how man can help us, but I'm not sure Oscar is here or not. It seems Oscar is not in the meeting. So anyway, if anyone could capture something through the online tour, that will be much appreciated. But anyway, I asked how many to help the chairs. Blue sheets. So anyway, this will be automatically created based on your Meet Echo information, log information. So no need to do anything. And for the IPR process, though this is quite very important reminder about the IPR process. So usually, prior to moving to the next step in the working group process, uh, the chairs will send out the IPR polling, and then which requires the authors and the contributors of a draft to respond to the IPR polling as soon as possible. Otherwise, it may delay your draft to move forward quickly. Next. So another reminder about the mailing list. We always, encourage the working group to use the mailing list as much as possible, and we can, for example, discuss any open issues to some drafts, and also we can introduce some new drafts, and to attract more, interest from the working group, and also we could, introduce or discuss some potential new topics of the Ccamp. And also be aware that the working group consensus is determined on the mailing list, even though if we get some consensus in during the meeting, but we still need to bring it to the list for confirmation. Next. Okay, it's for you, Daniele.
Okay, let's see if it works. So, a brief update
on the document on the status of the documents of the working group. Actually, we have two documents in the ISG processing. The applicability of GMPLS to OTN beyond 100 gigabits, and which has been there for a while now, and they recently pushed young model for FlexiGrid topology. I would like to thank Adrian once again for volunteering to be the shepherd for this for both of the documents. Actually, we have 5 working group documents on agenda. We have the microwave topology young model, the young model for OTN slicing, the young model for layer 1 service models. It's all young models, basically. The optical impairment topology and the RFC 1993 BIS. Then we we are running the IPR polling for the layer 1 types and the OTN topology young. If I'm not mistaken, we received all the replies for the layer 1 types, but we are still missing 2 or 3 of them for the OTN topology. So please answer to the polling as soon as possible so that we can start the working group last call. We would like to run a joint last call for both of the documents. Then we have the OTN tunnel model. This one has been updated with consistent description on terminologies, tree diagram, and prefix. It's technically stable. I mean, the authors said that they are trying to keep an alignment with the generic model. Actually, this is one of the many documents that have dependencies on the IETF document from TIS. We have also the transport and DI applicability statement. This is a document that already went through the working group last call. All the comments have been addressed. This is a pretty long and extensive document. We tried to reduce a little bit it. We reviewed it, trying to cut some fat and just leave the meat around the bones. I don't know if Italo or Dan have some updates on the progresses of the diet of the document. Please, Italo or Dan, if you can hear us. Okay, Italo, please.
I don't see that. So we have looked at your suggestions, and we are going to review the document and update based on your suggestions. But we still need to do the work. Thank you.
Okay, that's fine. I mean, at least you're fine with them. That's already a good starting point. Moving on to the other documents. These ones are so we have the client signal young model. There is a number of pending issues, resilience, port layer, etc. The authors are working on that. Then we have a set of documents which is moving a little bit slow, but I mean, I fully understand that because we have a fairly reduced number of authors which is working on many documents in parallel, and it's of course some of them are progressed with low priorities. We are speaking here about the DWDM interface LMP extensions, but if I'm not mistaken, this is applicable also to the DWDM interface parameter young model. Then we have the young model for Flex Ethernet, which was recently adopted. There was quite good support, but after the adoption, no big changes on the documents. So a little bit more more discussion and more review from the entire working group would be great. Then we have two documents, basically the tunnel model for WSON and for FlexiGrid. These are both pretty stable documents. They have been out for a while. Both of them are blocked by the IETF TE model. We were considering to merge the two documents since both of them have common layer 0 attributes. So, I mean, this is something that we would like to discuss to reduce the effort from the ISG, from the reviewers to analyze a single document instead of two. Finally, we have liaisons and communication. We have two of them. One from the ETSI ISG. This is a follow-up on the Young modeling for SDN SDI. This is mostly focused on microwave, if I'm not mistaken. And this the liaison is to announce the next round of plug test arranged by ETSI. You can find the link to the liaison here, but you can find it also on the mailing list. This was just for information. We have also another liaison which we received a couple of days ago, so pretty fresh. I just scanned through it. This is a liaison on invitation to update the information in the IMT 2022 and beyond roadmap. So if you're interested, you can find a link to that as well here and on the mailing list. If there is no comment, I would move to the first presentation, which is the Young data model for microwave topology. If I'm not mistaken, Scott is presenting it.
Hello, can you hear me all right out there in
Yes.
Chairland? Okay, great. Well, welcome everyone to the Yang session for Ccamp. It seems to be something that's very popular these days. What I'm here to do is just to present very quickly a update on where we are with the microwave topology Yang. It's work that's been going on for a while. We have a team, the team that's up on there that are the authors of this update to the draft are ones that we participate in conference calls like every 2 weeks. So if you're interested in this work, we do have a lot of conversations. So please join those. If you go to the next slide, please. So the status is very simple. We've taken the work that we were doing before and we've migrated it all to GitHub. We're using the GitHub templates from, I think it's Martin Thompson. And so we're using that to track our issues. So if you're interested in this, go there and you can see where we are and see the latest drafts. We had minor changes, very minor changes to the Yang module. We've completed the topology model figures, fixed and validated things. We've added some instance data, and this is from Daniela. She did a great job on producing some more examples so that you can see instance data and how it is used. And we validated that using tools like YangLint. So if you go to the next slide. So what do we have for issues? So if you're interested in some of the issues that we're currently still working through, and there's some tweaks around bandwidth utilization, and there's a pointer to the issue, and an issue around operational mode. And this is something where we're trying to decide how to model the operational mode and trying to decide if we need to update the 8561 to support a different way of supporting operational mode. So if you're interested in that, I have a private draft that I've started. It's not public yet at all. There's no 00 or anything yet, but there is a GitHub for that as well if you're interested in looking what we're thinking of doing there. Next slide. The liaison that Daniela just talked about is this ETSI liaison from the microwave working group. This provides a little more background on it, and if you're interested in this, I like this type of work because they're using the yang that the IETF creates. They're using it in plug fests and actually validating that it works and finding issues and reporting back. And those are all very useful things. So there is a new an invitation here on what they're going to be doing next year. So if you're interested in this kind of work, especially around topology or around configuration of microwave, that's what this is about. You can find more work there and find background there. So go next slide, please. We're going to try to get the draft. We want to get all of our issues done and get all that stuff done and try to get a last call by next IETF. Next slide. I think that's it. Is it the big thank you slide or is it the big empty slide? I don't know. What's next?
None of them.
None of them. Okay, so it's so we have Adrian in the queue, and Adrian's in the room. How about that? So hold on a second.
Thank you. So we're in the room, but we've only got one functioning microphone between us. Hi, this is Adrian. I'm standing here looking at Scott, which is kind of surreal for an online meeting. So thank you for respinning this draft. And I know you do all the work in GitHub and so on. Could you do me a favor and try to keep it alive going forward? Because it's really hard, as you say, when people outside are picking up this stuff to use, and they can't quite tell whether we've abandoned microwave or not. I've been fielding questions on that.
Oh, thank you very much for that. Yes. One thing that we're trying to do is do a lot more with our meetings and publicize this using the GitHub tooling. But something that we should do more of is when we have a meeting, we do put the minutes in GitHub, but we should do a better job of putting it out on the mailing list as well. That would help people see that the work is still progressing, especially if we're trying to get to last call by next meeting. We need to start doing these last two issues and make sure that the mailing list sees the work as well. That's a really good input. Appreciate that. Anything else? I don't see anyone else. Fatai's requesting the floor. Go ahead.
So I have, can you hear me?
Yes.
Okay, I just have one, open question for discussion. So far, actually, there are two drafts about young models for microwave. One is this draft about microwave topology. Another one is RFC 8561 about the young model for microwave interface. So I'm wondering, I'm wondering if it needs a draft to define young models for tunnel stuff like OTN tunnel or WSUN tunnel.
Well, that's I'm going to answer it the way a good chair would answer that. If you feel that there's work that's necessary in that area, please submit a individual draft, and then we'll look at doing that work. I think that there's the work to be a little more serious in my answer. The way that we're trying to do this work is we're trying to do it in a very modular way so that if people want to have things that run over top of this, it's easy to create augmentations that will then you do the new functionality. So hopefully that answers the question in a sensible way. Thanks.
Okay, thank you. Yeah.
All right, thanks everyone.
Thank you, Scott. Well, actually, I didn't have the feeling that this work was stopped, probably because I was following the minutes on GitHub, etc. But Adrian raised a very good point. Sending a link to the list would be definitely helpful.
Well, my response to that is just because I'm on the floor and nobody's requested it yet. I think that it is very useful to remind people to do this sort of thing, to continue the discussion on the mailing list, even if you're using GitHub, to make sure that the entire working group knows what's going on. So thank you.
Yeah, definitely. Next one.
Hello. Daniel, you wanted me to control it, or you can help me control the slide?
I can do that for you.
Okay, perfect. So hi, everyone. My name is Aiwa, and I'm here presenting the second revision of the draft for the framework and data model for OTN slicing on behalf of the co-authors and the contributors. Next slides. Okay, so since the last revision, becoming the working group draft, we have updated both the text as well as the Yang data model for OTN slicing. So on the text side, the main change is that we added a section that describes the realization of OTN slices with network resource partition, along with other cosmetic updates for the Yang models. So basically, there is a Yang model for the northbound of the OTN slice controller, which we made a shift from originally a standalone Yang model into an augmented model based on the model defined in the TEAS working group of network slicing and BI Yang. And then we introduced the constructs that are common for transport and network slicing. And then we move along with the definition of the models. So you could see on the right, the model relationship for the northbound interface being network slicing Yang at the bottom. Then we introduced the transport network slice. And then next will be the OTN slice, which contains OTN technology specific attributes. So on the MPI, basically the southbound of the OTN slice controller, we renamed what was called IETF OTN slice into IETF OTN slice MPI for the obvious reason that we wanted to reserve the name of IETF OTN slice for the MPI, for the MBI. Next.
Next slide. Prefer it now or at the end? I have a question here. Do you prefer to take questions now or at the end?
Yeah, we can take questions now.
Okay. So my question here is, here you used the IETF transport network slice because I guess here it's a common layer between OTN and other transport layers, like for example optical, I guess, or I don't know, Ethernet or whatever we come. Okay. So no, please.
The intention was to make the transport network slice a common layer that applies for all transport network technologies, including OTN, optical, and microwave, possibly. Right?
So, I mean, it has already been done for the common types, like the layer 0 types, layer 1 types, etc. Probably it would make sense to extract it from here and have it in a dedicated document, because I mean, one day if we want to build a specific I don't know, WDM slice or a microwave slice, having the common transport network slice defined inside the OTN document is a little bit ambiguous, I would say. So I mean, this is just my preference. I'm not asking you to do that. I'm asking the working group if what's his opinion here. We can take it to the list, but I mean, I just wanted to raise to raise this point. If that's a common module, I would remove it from the OTN slicing document and make it common.
Yeah, sure. Chair, so that's a good suggestion. We definitely can discuss that, and then basically can move it to a common model that applies to all transport technology.
Yeah. Sorry to interrupt you. Dhruv, is that a reply to this question, to this comment?
Specific to what you just said.
Okay, please go ahead. Sorry, if you are.
Yeah, I think what is currently happening is the IETF OTN slice that is currently not defined. There is a section, but that section is currently empty. And what we basically have in this document is the IETF transport network slice. So what confusion is happening is the document is called OTN, but the Yang model that is currently the main focus is the IETF transport network slice. So I've urged the authors to think a little bit more and come up with a good strategy. Like, maybe we even have to rename the document if that comes to it.
That's an
Yes,
option. We can dedicate this document to the transport and network slice and have in a separate one OTN specific augmentation. That's fine as well.
Yeah, I see Sergio in the queue. Sergio.
A short answer. Yes, he is right. It's partially right in the sense that from NBI perspective, you're right. So there is nothing specific for OTN, but the document is considering also the MPI extension. And for that point, it is specific for OTN. So this is why we have not changed nothing for the moment, but surely the suggestion from transport network slice that can be a different, a separate document is a good suggestion. But the point is that at the moment the model is dealing with two different type of model. One for MBI, and this is an extension of the draft in which Drew is working, and the other one is for MPI. Thank you.
Okay, Italo, and then with the presentation.
Yeah, I agree with Sergio. And on top of that, there is also a framework which is really OTN specific. So it's only the transport network slice, the YAM model, which is generic. So maybe we can figure out how to split the two pieces into two documents.
Yeah.
Okay.
So thank you.
Sounds good.
Italo. Let me just complement what Italo has said. So from the YAM model development perspective, we wanted to have the basic framework for transport network slice ready as a generic model, and then we know what exactly we could put over the OTN slice model. So basically, we do it as a step-by-step approach. But as I also agree with the chairs and other comments, we could consider separate those two models into two drafts. We could discuss that over the mailing list after the call. Okay, so yeah, next slides. For the consideration of using NRP for OTN slicing, so from a constructor point of view, what we see is that NRP could be used to resolve the scalability issue that are mostly applicable to packet networks and to help reduce the complexity of realizing slices in the data plane and control plane. So the NRP is a internal construct, but could be configured by the underlying SDN controller, which and the configuration could be pushed through the MPI to facilitate the slice realization. So now for OTN and possibly other transport networks, The resources are like much coarse granular because of the time TDM nature of the network. So in this case, we could see that the use of NRP is still optional, but certainly will have its benefit to support large-scale networks. And also, if we consider that in the future, when we see, for example, OTN data plane will start to evolve. For example, there are proposals about considering to develop a sub-1 G OTN. So in that case, then the complexity of supporting slicing for OTN networks will also become much more complex. And then in that case, the use of NRP has certainly has its benefits. So all those text has been put into the draft for the consideration of the audience. Next. Yeah, so we put in the draft a diagram about how we could realize OTN slices with the NRP. So from the diagram, you can see the NRP is used to map OTN slices from external configuration into an internal topology, right? And that each of the NRP topology is linked to an underlaid OTNT topology, which is received from the OTN PNC controller or MDSC controller from the southbound. And so basically, the OTN slice controller could choose to use the NRP for resource reservation, right? And in that case, we see that the cardinality between OTN slice topology and NRP topology is 1-to-1. So in that case, then we don't need to specify to directly basically make a coloring configuration on the underlay T topology. But if the NRP topology is not used, then when the user configures multiple slices and decided to map it directly onto the underlay topology, then we will need to sort of color each of the resources of the underlay topology and send it to the OTN PNC controller. So that's the two options that we can see of using NRP versus not using NRP. Next page, please. So on the Yang model ends, this is a brief glimpse of the Yang model for the transport network slice. So basically, it introduced a section of network topologies in addition to the base model from TEAS. So from a northbound perspective, a user could configure a transport network slice by specifying topologies. And then it could also designate an explicit path based on the topology to each of the connectivity constructs. Okay. Next page, please. So there are a couple of open issues of the modeling. So one open issue, which also has been mentioned in the TEAS network slice Yang modeling discussion, is how we could define technology-specific attributes. Right? So currently, the design in the TEAS network slice Yang is to try to use an opaque definition of attributes that can and try to capture technology-specific parameters, and they are in the form of key value pairs, right? So what we see is there might be some issue with this approach is in that the most important part is there's probably need to be a implementation agreements in addition to the Yang model to make sure full interoperability could be achieved because the attributes are more opaque and you don't really know what is what's the meaning behind those opaque values, right? And some other concerns is about those opaque values could not be explicitly validated with the Yang schema, and it may have an issue capturing complex attribute structures. So with regards to OTN slicing, our preference is to go directly with explicit and technology-specific attributes, and probably we're not going to use the opaque definition of the attributes. But that we'll continue working on that and to discuss with the network slicing Yang team and try to figure out the best way to move forward. Dhruv?
Question at the end. Finish your presentation.
You wanted to ask a question, or you want me to move forward? Oh, okay.
Because I have multiple questions, so it's better to do it at the end.
Okay. Yeah. So, okay, next page. Okay. Another issue is to, so right now we could see there could be multiple options for the MPI model. One using NRP and the other one of not using NRP, and in which case we identified some gaps in the current topology, and we added an option for coloring the links in the model, right? So the question is really if we define a standard draft, whether it is necessary to include multiple optional MPI models, or we it's better for to go with one option. So that's something probably we could raise this to the working group and see what we can do with the model. Okay, next page. Okay, here are the next steps. So we are to address open issues, and then we continue to work with the network slice MPI Yang and to align the two models. And also we are going to define OTN technology specific models based on the common transport network slice model, which includes adding technology specific SLO, SLE for OTN, and we are to support both connection-based and resource-based slicing. And also support for multi-technology links, like those links with which is non-OTN. Yeah, and the GitHub repo, and we have a weekly call every Thursday. So we would like to welcome and more participants, and we like to receive more comments from the working group. Thank you.
Okay, Dhruv and Adrian, and then I closed the queue because we are already 10 minutes late. Please.
Yeah, I'll try to be very quick. With respect to NRP, I think we need to also clarify, would there be any interaction between NRP in the IP layer and the NRP here? Or are they going to be completely independent? Because that was not very clear from the document. And related question from the Yang modeling, since there is a model for NRP in T's, would there be any interaction between that model? Is that model also supposed to be some kind of generic model, whereas the NRP OTN is going to be something specific? These things are not very clear from NRP point of view, so I think a little bit more thought is needed. The second thing which I wanted to talk about was the topology part. Since we have added that topology in the model, and we had one discussion in the T's also, that what if the T's model use the VN type 2 mechanism, where we put a reference to an abstract topology, same as what we do in VN type 2. 2. Would that meet your requirement, or you still need a topology, which is a generic topology, which is based on the VN type 2 mechanism? So that is the second thing which I wanted to talk about. Was the topology in the separate from that in the T's. So like think about that and like, discuss with the T's authors and let's come up with a good solution here. Thank you.
Okay, let me make a quick comment. Yes, so I agree with you. One of the main driven factor for defining a common model for transport is we don't have an option to specify topology in the base model. So yeah, but short answer is it depends, and then we could discuss that offline to figure out the best way to have the support for topologies.
Hi, it's Adrian. I wanted to just take the time to say thank you for doing the work to integrate with the T's slicing service model. Since I asked for that, the document's much cleaner as a result. And then since the discussions moved in that direction, we do need to step back and try to understand whether a slice is supposed to expose anything about the underlying topology in that concept of a slice service. And it may be that the type of work that we want to do here exposes topology, and therefore we should stop talking about slices and continue to talk about virtual network topologies. And if we want to integrate ourselves with slicing, we have to understand that the slicing service, a bit like a VPN service, has an opaque view of the underlay.
Thank you. Thanks a lot. Next one is Aumiana.
Can you hear me?
Yes.
Okay, thank you, and good day, everybody. This is Han Mian from Huawei, and I'm presenting this Layer 1 connectivity service model on behalf of all the authors and contributors. Next page, please. Yeah, so this one is a brief update on the status, and it has been a while since our last presentation. It was in IETF 109 for version 13. And after that, we have actually a few updates over there, but I think the major one would be to address the comments in the Young Dr. Lasko review. We provided a more detailed description in some of the lib notes, and we moved the JSON example to the appendix. So basically, it was trying to clarify those descriptions in the models that may cause some confusions. And we are having one GitHub repository available on this Layer 1 CSM, and we check it out because it's very close to the working group last call, and we figure out there are two issues to be discussed. So that would be the next 2 pages. Next, please. And the first open issue is actually a high level one. The question is about, okay, how to coordinate the performance monitoring stuff regarding the Layer 1 connectivity in this document and in other document. So our current scope is we are coordinating with a performance monitor metric specified in MEF63, and it would be useful if we could also reconcile with ITUT document like G.A26. But we also received some comments say whether it is useful to coordinate with other PM models like the one in our working group as an individual draft, the client signal performance monitoring, and some other like the VPN PM, IP PM, and whatever. So yeah, well, but that part of the work is just starting, so we are providing a few options that can be considered as resolutions. And the first option would be, okay, how about if we remove the PM related part and proceed it and leave this work to other TPM models. And this one is the authors are having some kind of preference to this option. And The second option would be leave it with only math 63 alignment, and option 3 is well, okay, we should redo the PM part. I see John the Mac. No, the next page, please. Okay, and the next issue is about the descriptions in the yarn itself, and the problem was, according to MAP63, the configuration of the protocol coding function and interface functions attributes should be consistent, and there are some kind of constraint when given the when people give the definitions of such kind of parameters. We were trying to describe in the Yang grammar, but after checking with Yang experts in that model, we find okay, this is not achievable, and we finally decided to tweak only the descriptions in the module. So we will do a review, another iteration of global review, and update it to the description by adding the constraints. Okay, next, please. Okay, then I think we at least to discuss about the 3 options for issue 1, and if we can reach an agreement, we can do an update and request working group last call, and that's all for the draft presentation.
Thank you. So I would suggest to, I mean, since we are pretty close to the last call of this document, I would bring the 2 open issues to the mailing list, so to see what's the opinion of the working group, and then I think we are done.
Daniele, sorry to interrupt you. There is some problem in the meeting room.
Yes,
can you check the chat? Okay.
I can't see the video any longer. I didn't know if it was my problem or it's in the room.
No, it looks a problem in the meeting room in Philadelphia. Look at the chat.
Okay. Network issues. Okay. But the others can still hear.
It looks like remote people.
Offline part is good.
Yes. It's the on-site people who are disconnected.
But we lose the video, from the
video.
Let's move on then, since we are already pretty late. So we have slot 4 presented by Sergio.
Okay. Good morning, good afternoon, good evening, depending of location. So I'm Sergio Bellotti. I'm going to present the update of the optical impairment topology model on behalf of co-authors and contributors. Next slide. Okay, so as we have a weekly call, the major activity since IETF 413, we have the usual weekly call on Tuesday from 2 to 3 p.m. Everybody is welcome to attend, and so the meeting is open and welcome to host other people. We updated both the text and the Yang model. The first update has been done related to an issue that is there from a while. Is not trivial, so I mean we started to have a general refinement regarding the OTSI terminology alignment with G807. We have not completed that, in the sense that surely before to have a stable version and to be ready for last call and Young Doctor review, we need to have a complete review on that. But we started to do that. We added a section at the 2.3 section to clarify the relationship. So first, to clarify why we need to have OTSIG information in the context of the topology model. And what we agree is that the presence of the OTSIG is important in the view of the OTSI global unique identification. So in the model, our approach is to have a hierarchical approach in which we have an OTSI group ID that is identify uniquely the OTSIG in the network, and then the contain OTSI identifier that is providing the local scope of in the context of a specific OTSI group. There is a lot of noise. I don't know if for everybody is the same, but well, okay. Then we added a section regarding unidirectional 3R. So the point is that in the case of unidirectional transponder, unidirectional 3R, the transceiver of each optical transponder receive the signal from one send and transmit the regenerator optical signal in the adjacent segment. So in the case of carrier, for the carrier frequency, we can operate a different frequency, optical frequency between the receiver and the transmitter. But in the model, we have defined the transceiver capabilities, that is the transceiver mode. And this is a property of the transceiver. It is applied at the same time to the transmitter and the receiver. So the transceiver mode has to be the same in the two segments of the two sides of 3R regenerator. So for this reason, the transceiver mode cannot be changed in the context of unidirectional 3R. We added specific tests for that. And then we started to have a new section regarding the protection architecture. For the Young model, we fix two issues that is basically regarding the tilt target. To clarify the context of the tilt target, it is related to the upper and lower frequency of amplifier. We introduced modification regarding the protection modeling. This is a work ongoing, but we started on that and we started to make a modification. And we have other issue that is impacting the Young, but these are fixing in the context of IETF layer 0 type, but is still related to the optical impairments. Next slide. Okay. So we said that we started to work on the optical protection. So in case of the optical protection, as depicted in the up part of the drone, at the splitter, the signal is optical duplicated before entering to the add drop part of the ROADM, and at the selector, one of the two signals from the drop ports of the ROADM is selected. There is no problem in that. You have end-to-end OTSI, single one. In case, but the problem is in the case in which you have one of the leg that is with the 3R regenerator, because in this case the path, the end-to-end path OTSI is is broken, and we have no more end-to-end OTSI. Next slide. So what we need to have in the topology model. So in the topology model, the path computation need to know the existing OTSI in each OMX section, for the reason to determine what are the optical impairments of the existing OTSI on the calculation of the optical feasibility of the new OTSI, and the opposite. So the impact of the new OTSI with respect to the existing one. So in the case of protection, the question that the authors put on the table is how to represent the existing OTSI already there in the network. So we have two optical signals at the input of the selector that may have optical impairments impact because is linked to the different paths. And in case and the optical feasibility has to check anyway in the two paths, because we need to be independent of the action related to the switching for the protection. So our solution, next slide, for the representation of the OTSI is to have only one OTSI, but with representing all the associated path related to the OTSI. So in this case, that is related to the same picture of slide 3, we have one OTSI, but we have an impact of the optical impairment with different 3 paths related to the same OTSI. So in the model, from Young perspective, we associated to the OTSI with a list of paths that we name NNC path. There is a basic physical assumption that at the ingress and egress of a splitter and selector, the OTSI identifier is the same, and the NMC are different. The NMC paths are different. In the same way, in the OMS section, we will have the reference to all the OTSI and the reference to the related paths for each OTSI. Next. This is the modification of the Young. On the right, on the left, we have the definition of the OTSI G and the related OTSI. And for each OTSI, we added a list of related NMC path identifier. At the same time, in the context of the OMS section, we have the media channel group, the OTSI G that is related to the specific media channel, and the list of the OTSI related with the specific related NMC path specific to that to the OTSI. Next. So what are the open issues that we are needed to work on? First one is that we need to complete the optical protection switching. That is work ongoing. Then there is the model. There is an issue related to supported remote optical transponder. The model is already able to support the remote optical transponder connected to the WDM node, but we need to explain in a specific text how the model is supporting the different scenarios. There is an issue that is related to the XPath in the LeafRef. We discussed with experts like Rob and so on about the net mode. In the net mode, because we have in mind to use ancestor function, but there is still debate on the topic. And for example, in the context of the flex grid, we practically decide to come back to the relative path. There is a need for a review of technology that has been addressed partially, and that there is an issue related to the boundary between layer 0 and layer 1, because the model, there are some functionality like FEC, inverse multiplexing, that is a layer 1 functionality, but is in the scope because it is related to the transponder, so is in the scope of this document. And we need to clarify in the text that. Then there is a specific issue that is related to the process improvement, and a new one that is related to the usage of container. Is not a big issue, it's just a need to review when the use of a container as immediate parent of a list is really needed in the model or not. We have our GitHub, and there is the minutes there is all the issue that is described, so everything that is summarized here, you can find that in the GitHub. Next step. Okay, we need to complete the OTSI protection model. We addressed the representation of the OTSI, but we need to adding the report optical protection capability, including OMS protection. We need to address the rest of the list, the issue that at the moment are 8, if I remember well. Analyze possible enhancement apart protection that we should cover as feature. And the intention would be to have a stable version by next IETF 115, and then be ready for a young doctor review. That's all from my side.
Thank you. Questions?
Welcome.
I'll prepare the next slides. I don't see any questions. So Sergio, you probably can start with the 1993 bis.
Okay. We have a first presentation last time about the RFC 1993 bis, and these slides represent the fact that we changed the co-authors because we encompass the cover part of both the documents, so the original RFC 1993 and the layer 0 type extension draft. So this is why there is a long list of co-authors. Next slide. So a short background. So we have obsolete this document. The intention is to obsolete 1993, encompassing the content of the RFC with the layer 0 type extension drafts. There is a specific GitHub, and basically the work has been started in the view to match the comment received at the IETF 112. We have restructured the document, draft IETF layer 0 type extension, to become RFC 9093. Now for IETF 114, we fixing the issue 48. So the content of the layer 0 type extension have been moved into the layer 0 type Yang. So we have only one module encompassing all. And we deleted in the repository the IETF layer 0 type extension Yang. We fixing a lot of issue for this IETF. Partially, there are 3 issues that, as said before in the presentation for optical impairment, that is directly related to the optical impairment topology model. Next, thank you. Okay, this is a first issue that we fix. We added a new modulation format and the description that we realized was missing in the model. Next. Here, practically, the 32 and the 33 is related to fix a wrong reference from the left. We have modified the reference in the definition of the operational mode. There is a wrong reference for the IQT. Instead, we added in yellow in the slides the specific reference of the section in the optical impairment draft in which we describe what does it mean operational mode. On the right part, there is a wrong reference with respect to RFC 6205 in the frequency definition, and we delete that. Next. Okay, here we have fixed 3 related one to the other issue that is related to the penalty definition and the associated accumulated value. Originally, the model presenting the combination of chromatin dispersion and polarization mode dispersion with associated penalty. So was a triplet, list of triplet. Now we have a separate list of pair, accumulated effect, and associated penalty. And we also modified the penalty description, and we modified that align with also the strictly aligned with what OpenConfig is providing. Next. So this is the modification related to the pair of effect plus penalty. So we have now the list of chromatic dispersion penalty and polarization dispersion penalty. We have already the PDL related penalty already made with effect plus associated penalty that was in the original document. Next, thank you. We clarify the meaning of an attribute that it was originally provide a lot of discussion in the group. So we had the central frequency step, but there was some misunderstanding on the meaning, and we clarified that the attribute is dealing with the granularity of the transmitter tunability of the carrier central frequency. And so we have updated both the name of the attribute with the transceiver tunability and the description of the attributes. Next. We clarify the intention.
The time check. We are short
Okay.
of time.
Okay.
Can
Okay.
we go next issues? New issue. I don't know. Next steps probably.
No, just one point, briefly, shortly. In this one, we receive this comment from Yana, and that is correct, the comment. So we need to revise the section of the Yana as suggested in the comments. Next. So next step, we still need to reconcile the text in the introduction from RFC 1993 with the one from layer 0 type extension. And we need to complete the appendix A, in which we should list the changes from RFC 1993. And we need to fix the remaining issue that is provided in our GitHub. That's all for my side.
Thank you. Questions? Young data model for network hardware inventory.
Thank you, Chair. Can you hear me?
Do you hear me? Yes, perfectly.
Okay, thank you. Okay. Hello, everyone. I'm Chowder from Huawei. I'm glad to do this presentation on behalf of all the contributors. Our job is dealing with network hardware inventory management and provides the young data model which can be used in the northbound of network controller. Next slide, please. After last presentation in Ccamp, we have triggered some discussion on the mailing list to find a suitable working group to continue our job, but no feedback is received. So we continue to specify our job in Ccamp and keep some other working group informed. These are the updates to our job since last IETF meeting. For the first part of our work, we have added more attributes to the young data model based on the model defined in RFC 8348 and some integration experience. At first, we have identified some common attributes such as UID, name, alias, description, and location, which can apply to all the inventory objects. And secondly, for the component object of network element, we have reused most of the attributes from RFC 8348 with some refinement that will be introduced in detail in the next several slides. Please notice that these refinements are limited in the scope to our job. We don't plan to update RFC 8348. And third, for the rack object, besides the common attribute, we have also defined some specific attributes such as height, width, and depth. And for network element, we all agree that most of the attributes in RFC 8348 defined for component are also applicable for network element. The second part of our work is we continue the discussion of scalability issues raised in last version. The conclusion will be also introduced in the following slide. Okay, let's go with the refinement introduced at first. Next page, please. In the data model of RFC 8348, a component parent reference attributes is defined. With this model, if the RESTCOM client wants to find this component's grandparent or higher hierarchical level component, it needs to do the retrieval step by step, which is time consuming. So we suggest to provide a full list of hierarchical parent identifiers to reduce this repeated work. This model could also support more flexible retrieval function. For example, the kind can skip one or more component level to find its contained tried components. Okay, next start. Next page, please. After review the attributes defined in RC 8348, and we collected some requirements from operators, we think that there are some component-specific attributes missing in RC 8348. So we have designed a choice case structure as a placeholder for defining these extensions. The cases are distinguished by their class, so that different component-specific attributes could be defined in a separate container. The details in each of these specific info containers are still under discussion. Next page, please. This is a minor change. In RFC 8348, the preferred value for module name of a component is part number according to the Young description. Actually, the part number is more recognized term than model name, so we have renamed the attribute to part number directly. Next page, please. Here is an open discussion about the design of location. In RFC 8348, there were two attributes named by physical index in parent relative position, which can be used as location info. But if the kind want to have a component's absolute location, the client needs to retrieve its parent component one by one. We're currently evaluating two different design approaches to solve this problem. The first option provides a hierarchical structure, just like the parent identifier list in previous slide. This design can support similar flexible retrieval like I mentioned previously. But this structure is less flexible and risks to be applicable to optical network element only. The second option is to define the location as a string attribute. For optical network elements, a string pattern can be defined to contain similar position information like option 1, but because it is a string format, a different pattern can be used in other scenarios. So the same, so we consider this option is more flexible. But the same concern is we are not sure whether this string pattern is applicable only to optical network elements or not. But we have noticed that in OpenConfig, OpenConfig also uses a string pattern to provide location info. Okay, next slide, please. And for the discussion of scalability issue, we have checked all the discussion progress in GitHub. If you are interested in the discussion progress, you can have a look at the issue 32 in GitHub. Here we just want to introduce our conclusion due to time limitation. We think that the scalability issues will surely happen in big networks, regardless what kind of young data model is adopted. And this issue can also be found in other data models integration, such as topology and service, autonomous, etc. The root cause of the scalability issue comes from the limited transfer capability of HTTP protocols. Maybe some other export mechanism can help to solve this problem, but it is truly out of scope for our job. The full synchronization scenario usually happens on day one at day one of the first integration. The API used mostly in daily maintenance are never element based. And there were limited data in one never element, so the scalability issue may be less impacting as originally. We have also considered an alternative model which define inventory object directly instead of a generic component. So it's much easier to understand, but it would be less flexible to support new inventory hardware type than defining a generic model object as done in current model. So we plan to continue our work with our current model. Okay, next page, please. As a summary, we have introduced attributes discussion and scalability issue discussion today. And for the next step, since we have decided to continue to move forward with the current model and enrich a lot of attributes on it, we think that our draft is now ready for Ccamp working group adoption. We are also looking forward to get some input from other technologies such as IP and microwave to cover more application scenario. And we also plan to post some more open issues before next IETF meeting. If you are interested in our draft, we warmly welcome you to join our discussion. And we have a weekly meeting every Wednesday, and you can find more information from GitHub. Thank you. Okay, that's all for my presentation today. Thank you again.
Thank you. Thanks a lot. So yes, just a recap. I mean, when this draft was first presented, we thought that it was a good idea to discuss with Netmod if what was the right place for it. And I mean, in the end, we decided to continue this work in Ccamp. Does anyone believe that this is not belonging to Ccamp? Maybe the question is mostly to John. Do you think? Well, of course, any progress will be discussed and aligned with Netmod. We will have a sort of a frequent liaison relationship with them about the draft. But I mean, if there is interest in the working group to progress the work in Ccamp, I'm pretty fine with that.
Okay, thank you.
Since you asked me, I'll come to the mic and answer, but my only answer right now is I don't have an intelligent answer for you. I'm sorry. So I'll reserve response.
Okay. Thanks. We can discuss this offline. But I mean, thanks a lot to the others for the progresses and to explain the issues and the homing of the draft. Thank you. Next one, we have now Italo, if I'm not mistaken.
Yep.
Please.
Thank you, Mr. Chairman. I'm Italo from Huawei. I'm presenting a new draft on OTM pack computation. Next slide, please, on behalf of co-authors and contributors. Okay, the initial proposal for OTM pack computation draft was presented in IETF 112, and together with WZone and FlexiGrid, and the feedback in the IETF 113 discussion was to split the OTM part on a different draft. So now we moved the OTM pack computation into this new draft. The work is quite straightforward. We are augmenting the path computation RPC defined by TIS with OTM technology-specific attributes defined in layer 1 types, and we are keeping these augmentations in alignment with the OTN tunnel model, since the path computation and tunnel models needs to be in sync. And at this moment, we don't have any major technical issues to move forward the document. Next slide. So the next steps is, of course, to get feedbacks and comments from the working group and progress it accordingly. We will keep alignment if there is any change in the OTN tunnel model which have an impact on the path computation. We will keep an alignment, and we will complete the document adding the security and manageability considerations, which are currently empty sections. And we believe the document is now ready for working group adoption. That's all. Thank you on the OTN path computation.
Yeah, just a very minor comment. Keep an alignment with the OTN tunnel model, but also probably the path computation model.
And path computation model as well. Yes, you're right. Yes.
But yes, I agree. I mean, it seems to be something pretty straightforward, in my opinion. I guess we have a similar presentation for the optical one, right?
Yeah. It is about the optical. And next slide. Okay, the document itself has not been updated. Yep. Okay, the document itself has not been updated, but as said before, we moved the path computation OTN, so the document is now focused and will be progressed only to address WZone and FlexiGrid path computation. Like before, it is an augmentation of the path computation RPC defined by TIS, and reusing the common types in the RFC 1993 bis and alignment with the tunnel models for WZone and FlexiGrid. So also this one is quite straightforward, even though we have a little bit more open issues given the complexity of the WDM technology. We are discussing those issues together with the FlexiGrid topology and tunnel model weekly calls on Thursday. And what we have done, we have reviewed some use cases for the WDM tunnel model and identified some changes to the tunnel common attributes, which has been reflected in the RFC 1993 bis draft update, which is a grouping used by our model, but it has been updated in that draft. Next slide, please. The major issue that, This is a major issue that we are facing now is whether we are able to merge the WZone and FlexiGrid path computation models. In the current draft, we have two models, and we can see that there are some things which are different, like the WZone and FlexiGrid specific labels, but there are a lot of items which are in common between WZone and FlexiGrid. All the WDM specific constraints like OSNR margin and layer 0 tunnel common attributes are really the same between the two models. And there is a desire to try to see if you can merge these two models into one model. We have a similar discussion also in the context of the tunnel model, whether we can merge also WZone and FlexiGrid tunnel models. So the suggestion here is maybe we need to investigate the technical impact, whether this is possible for both tunnel and path computation, and then we can bring the option to the working group and hopefully have the common approach between path computation and tunnel model on merging the two models, the WZone and FlexiGrid part. Next slide. Okay, what are the next steps? Okay, is still to progress the work, getting feedbacks and comments on any part of the document. We need to do some editorial update to remove what is now moved to the other draft to avoid any overlapping. We have to evaluate this option to merge the two models into one model. And as I said before, we need to keep alignment with the WZone and FlexiGrid tunnel models and the RFCBs, as well as the path computation model in the TIS. So if there is any impact there, with any change there which impact this model, we need to take into account and add the security and manageability considerations to the document. Nevertheless, even if there are more open issues here than in the previous draft, we think this open issue can be addressed through normal working group process. So we think this draft is also ready for working group adoption. Thanks.
Thank you. Yeah, I mean, you already said that. I mean,
ideally, we should try to keep an alignment between the tunnel models and the path computation models. If we merge WZN and FlexiGrid on one side, we need ideally to merge it on also on the other. Personally, I had look at it, and my personal opinion is that a merge would be possible. I don't see any major issue. Speaking about both the tunnel model and the path computation models, I don't know if you have found anything that could be a showstopper here for the merge. Have you, Italo?
Yeah, it's just to understand the implication in details. But yeah.
Mm-hmm. Okay, great. Thanks. Now we have the last presentation of the day. Iowa again, please.
Hi. Yeah, Iowa again. So I'm here to present a second revision of the draft that describes a problem statement and identify gaps when we are to connect the end user to the cloud with optical networks. Yeah, Daniele, can you mute yourself? There's a lot of echoes. Okay, so a recap of what is the motivation for this draft. Basically, it's simple. The cloud traffic can be carried over IP-based networks from end user to the cloud, but with that, we could also carry the traffic over and underlay optical networks to achieve high quality and premium services such as cloud VR, premium leased lines, etc. And this approach is not a replacement of IP-based solution, but more complements what has been available with the IP-based network system. So traditionally speaking, the connections in OTN networks are more like pre-configured static with a fixed mapping between the client services to the OTN connections in the network. So now with the cloud-based traffic, the traffics are more dynamic. So in order to make the optical network to better support cloud-based services, we would want to make the OTN more dynamically configured. And because of that, we are looking into the gaps with current control plane support for OTN networks. Next page. Okay, so a quick update, summary of the updates. So before this revision, we spent quite some chapters talking about the use cases, which a lot of the use cases are actually asking for requirements for OTN-based data plane. So this is not the focus for IETF. So we have moved and consolidated all those use cases into a description of within the overview section. And we clearly state that the data plane requirements are out of the scope for this draft. Also, in this revision, we added a gap analysis for the current control plane protocols. And we also started adding some framework description for this draft. Next page, please. Okay, so from the requirement perspective, so cloud services are usually hosted in multiple clouds that are in different locations. And in order to support that, we need to support multi-cloud access, and that multi-cloud access could be done by running layer 2 VPN or layer 3 VPN over OTN. So the support for the P2MP and MP2MP connections can be done by layer 2 and layer 3. With OTN, typically we still have just the point-to-point connections, but potentially we could have the control plane support also for P2MP and MP2MP directly over the OTN networks. Next page. One of the key problem with current OTN is if it's all static and pre-configured, then when there's a change in cloud traffic, we would need to ask the network operator or some tools to configure the network in order to meet the change in traffic. So that's where so the thought is, okay, if we have the OTN network to be able to understand what is the current traffic coming into OTN and what is their QoS requirements, then we could adjust dynamically OTN bandwidth and the OTN tunnel the connections through the OTN network to make to better support the client traffic. Doing that requires the OTN edge devices to be able to sense some information about the traffic and exchange the reachability as well as the client information associated with the PE nodes. And in order to be able to dynamically map the client services onto either existing OTN connections, or it could start creating dynamic OTN connections on the fly. And we are looking into how the current control plane can do that. Next page. So as we said, like there's potentially a gap with the current control plane protocols in order to communicate the client information between the OTN PE nodes. And doing so, so if we exchange information directly between the OTN PE nodes, if you look at the network, you would have to create like a mesh of communication between the PE nodes. But so instead, we could use a reflector, such as the controller, to help with the exchange. And so there needs to be a protocol between the PE nodes and the controller, between the PE nodes and the controller to do this job. So there are some possible solutions, protocol solutions available in the Ccamp space. PSAP LS or BGPLS could potentially serve the purpose. Now with the optical network, so we typically there's no BGP support on the OTN devices because also I think this is not an updated version of the draft, but anyhow, so basically there's no BGP extension support for optical networks, and we believe with PCIe-LS it could be a better candidate for the extensions. Next page. Okay, so in order to support that, what we need to do is on the PE nodes, we need to identify what type of services are coming into the OTN network. This could be done by inspecting, for example, packet headers that arrives at an OTN PE nodes, and the information such as source and destination MAC, source and destination IP address, the VRF identifier and VLAN ID, etc., could be used to identify the type of service. And then with that service information, the OTN network could create a mapping between the type of service and onto an existing OTN tunnel, or if needed, it can create a dynamic OTN tunnel within the network. And even further, if it senses that the traffic demand from the client has changed, so it could actually make some dynamic bandwidth change on a bandwidth adjustment on an existing OTN tunnel to meet the demand of the client service. Next page. So yeah, I think this one has already been mentioned. The service information could be reported to the controller and exchanged between the PE nodes. So when the PSAP protocol is considered, then we could define extensions as a PSAP report message. Next page. Also, on the configuration of service mapping, we need a control plane extension to push the mapping table between the service to ODU connections from between the two PE nodes, as well as between the PE nodes and the controller, which service has in the reflector. And in that case, when the PSAP protocol is considered, then we could define extension as a PSAP update message. Next page. Yeah, so just a few next steps. We could consider to integrate the framework section into this draft, which we have already started working on it with this revision. And then we'll prepare the draft to ask for working group adoption. And also, I would like to call for interest and anyone interested in this draft to join the work and contribute to this draft. And we also would like to solicit comments from the working group. And then based on that, we could start discussing about potential protocol extension. I believe this is the last page. Yeah, okay, thank you. Any comments or suggestions?
Thank you. I have two questions, probably two silly ones. The first one is so you're saying that the BGP is not commonly used in OTN devices because it's an overkill. I mean, BGPLS is much lighter. I thought it was pretty much common to have at least BGPLS. I'm not speaking about BGP, but BGPLS on a device. Isn't that?
Yeah, this is as far as I can, as far as I know, there is not much of a BGP use in optical networks. And also, like I said, there's no extensions for optical networks in BGP or BGPLS. So that's probably another gap that prevents BGP from being used in optical domain.
Okay. And the other question, so we have requirements like multi-cloud access, then we have service identification and mapping. I mean, going through the presentation, I had the feeling that this is not very different from OTN slicing, is it?
This is well, I mean, OTN slice is could be an application. So you could create an OTN slice by using the support for this cloud to user to cloud mapping. This is basically this describes a possible implementation at the control plane to support one type of OTN slice if you consider that. But the use of this work is mainly to introduce the service-driven capability for OTN, so that we could better support cloud-based services by directly running that over OTN networks. So basically, without OTNs creating OTN slices, you could still use this capability to support to carry OTN carry data center oriented traffic. I don't know if I make it more clear.
Yeah. Actually, yeah. I don't know if slicing is a subset of this scenario, or this scenario is the other way around. This scenario is a subset of slicing, but I mean, this is something that we can discuss. We have two people in the queue. Yilin, please.
I think we need some clarification among several concepts. One is the idea presented by Aihua, and another is the layer one VPN, and also the third one, the OTN slicing, just Danielle mentioned. To my understanding, the differences between for example, the layer one VPN and this idea is that actually we are the same using OTN as the underlay layer of the network. But for the overlay network, I think for L1 VPN, it is kind of carrying layer one services. But in this idea, I see a lot of layer 2, layer 3 services, because data centers always use the layer 2, layer 3 services than layer 1. So I think that's in my understanding, the key differences between layer 1 OTN, layer 1 VPN and this idea. And for network slicing, my understanding is that network slicing is only for the OTN resources itself, not touching on the overlay layer. I'm not sure if I understand correctly, but maybe Aiwa could, the author of this document document could check. Yeah, that's my comments. Thank you.
Yes, Yi, to respond to your comments, yes. So the OTN slicing does not care what kind of services is running. It just captures the requirement for the let's say a QoS of the slice, and then I mean, for me, this work could be used to serve as the realization of a slice in the OTN network with control plane. Okay, Dhruv?
Regarding the work that you are suggesting, extension for PSIP, are they really OTN specific, or are they quite general? Like some of the things that I see, which is saying identification for slice, that would be common whether it is normal network or it is OTN. So just think about that as well. It's because the work is already happening, and if you have any specific requirement, maybe we can try to have one extension which takes care of everything, rather than having OTN specific PSIP extensions for things which are actually going to be quite generic.
Yes, Dhruv, good comments. I think a lot of the definitions should be common. So I agree with you. We need to define the extensions as common as possible. I think it's not OTN specific, but could be used by this scenario to identify the type of services. Yeah. Okay, Italo?
Italo, please.
Yes. Hello. Okay, since there is time, I take the opportunity to answer to the question from Daniele. I think that it is both the subset that you mentioned. In other words, I think that this solution can be one way to realize an OTN slicer. So this is a subset of slicer, but OTN slicing can be one way to request to express the intent for a service that is realized by this solution, but maybe other way to request this service to be realized. So it's both and a subset of the slice, and the slice is a subset of this. Thank you.
Okay.
Thank you, Italo.
Makes sense. Thanks for the clarification. So, given this is the last session of the IETF meeting, I think you would be happy to have 5 minutes back and either run to the airport or go for dinner if you are in Europe and go to sleep if you are in Asia. Thanks a lot, everyone. Bye.
Bye-bye.
Bye, thank you.
Thank you. Bye-bye.